Now let us start with the load cell sensor. This is our load cell sensor and this is our signal conditioning circuit. These two are our outputs which are connected to this meter. Now, as you can see, here are two trim ports. One is for 0 second setting and one is for span settings. The holes are provided on the top so that you can adjust it with respect to your requirement. Now, first we will place a 50 gram load on the sensor and we will observe that it is coming 49, that is approximate, which can be also adjusted through this port. Now, we will place a load of 200 kg, 200 grams more. As you can see, it is around 250 grams or 248. And now, we will load the complete set and the total physical weight is around 500 grams and you can see the result is around 501, that is almost approx to 500 grams. This one error can be adjusted through this port. Now you can see the weight total is 500 grams. Now moving on to our last sensor, that is our magnetic sensor. In our magnetic sensor, there is a small sensor placed in front of the magnet which is sensing this magnet as the motor moves. This is our reset button to reset the value which is being displayed here. The value which we see here is the actual RPM of the motor, which is calculated via reed switch, and the calculation is done through this microcontroller. There are two connections in this. One is a sensor output which is given here, and you can also see the sensor output in a CRO through this test point, and ground can be attached here. The port provided here is for varying the speed of the motor, and as the sensor senses the magnet, the LED here blinks. The value here, which is right now 1077 or 1067, that is actually the RPM of the motor, and it can be increased using this port. Right now, the maximum RPM which can be read is 2665, that is around 2600 RPM. And the minimum RPM which can be achieved is 333 RPM. Now we are going to start with our strain gauge strain circuit. This is our strain gauge sensor. This is our place for placing the load, and this is our meter. We have switched the reading to strain gauge. As you can see, we have three options: LVDT, strain gauge, and thermocouple RTD. We have to keep it to the center position for strain gauge. There are only two connections in it. First one is for the meter and the other one is our two bridge connections, A to X and B to Y. Then we will start by placing our first load, that is our 50 gram load. By placing it, we are getting a value of around 112. As you can see in the manual, the reading for 50 grams is approximately 111, that is around 111, 12, 13 or 14. Now, by increasing the weight more by 50 grams, we can see the reading of 227 and 226. That is equivalent to the strain of 100 grams on the cantilever beam. Now, moving on to our next sensor, that is the thermocouple and RTD. We will first place the meter. As you can see, the ground is connected to J4 and the positive to J3. Now comes the process of connecting the sensor. In this sensor, you can clearly see there are two terminals, blue and yellow, which has to be connected accordingly. Basically, the blue is the cold junction and yellow is the hot junction, according to the thermocouple settings. Now we will turn the reading for the meter to thermocouple RTD, that is the rightmost position, so that we can get the equivalent reading according to our sensor. Here, which you can see on the above, is the schematic diagram of our amplification circuit, and in the meter you can see 24.5. That is the basic temperature in degrees Celsius. that is the current temperature. You can also see the readings and intermediate stages at the different stages of amplification at TP1 and TP2. Now moving on to the RTD. In RTD, firstly we have to change the meter setting from ground to ground and J7 to voltage. Now we will have to put our sensor. This is our RTD sensor. The connections are quite simple. The black goes to J5, the black terminal, and the white goes to white. What you see here is the equivalent temperature with respect to our RTD sensor. That is also around 21 degrees Celsius. Here also there are junctions, so if you want to see the intermediate value, you can check the value at J6, and for CRO probe you have J5 so that you can connect it to ground. Now we are going to start with the load cell transducer. In the load cell transducer we are going to use this sensor. This is our load cell sensor. This is our 9-pin D-type connector, which is with the angle setting, so that you cannot insert it inwardly. After placing the sensor, we need to use our different meter. You can see here it is written 200 millivolts for load cell. First we need the connection for negative and positive. These two connections will go to here. Now we'll start with our basic load, that is our 50 gram loads. As you can see right here, that the readings are quite different, so that in order to solve that problem, we can use the setting by turning the port from R6, 16 and J5. These two ports are used for span and zero settings.